feel free to pause this video so that you can attempt the question and then press play so you can go through the solution with me. We have here a triangle with vertices A, -5, 7, B, -1, -5, and C, 13, 3. And the broken line represents the altitude from C. So from C, this line here is the altitude. We have to show that the equation of the altitude from C is this. So we've been given the answer, we just need to prove that. So if you're working out the altitude from C, what you need is a perpendicular gradient. Okay, there's my right angle here. So I need to work out the gradient of AB first to then get a perpendicular gradient, and then I need to substitute in the coordinates from C so that I can get this equation. So step 1. Make sure you label everything. So gradient of AB. Your gradient formula is y2 take away y1 over x2 take away x1. So look at your coordinates carefully. 7 subtract -5. And -5 subtract -1. 7 plus 5 becomes 12. -5 plus 1 becomes -4. So our gradient of AB is -3. The next bit of working would be to find the perpendicular gradient. So if we have -3 over 1, flip that and change the sign, and we get positive 1/3. If you were to prove that, you would just write this is since -3 times 1/3 equals -1. Then we need to substitute our coordinates 13, 3, since it's the altitude from C. That's going to be my A and B. And my perpendicular gradient, 1/3. I'm going to substitute that into the y minus b formula. So my b is 3, y minus 3 equals 1/3 x minus 13. When you have a fraction for a gradient, multiply everything by 3 to get rid of the denominator. And that just breaks the bracket if you've got a 1 for the numerator. I'm going to add 9 to both sides. And then divide, oh sorry, I'm not going to divide by 3. I'm trying to get x minus 3y equals 4. So all I need to do is move the 4 over to the left hand side and move the 3y over to the right hand side. So rearranging this gives me x minus 3y equals 4. So that's the final answer. The next part of the question is to find the equation of the median from B. So what I'm just going to do very quickly is copy this picture over. Okay, so I'm trying to find the equation of the median from B. So median, middle, from B, I'm going to draw a line from B coming to about here, and I'll call that M for the midpoint of AC, and that's the median from B. Okay. So if I want a median, I have 3 bits of working to do. I need to find the midpoint of AC. I then need to find the gradient of BM, and then I need an equation, so I'll substitute in the coordinates for B. So, first bit of working, midpoint of AC. And that is denoted as an M. So I'm looking at A and C. The midpoint formula is to add the x's and half them, add the y coordinates and half them. So looking at A and C, -5 plus 13 over 2, 7 plus 3 over 2. -5 plus 13, or 13 take away 5 is 8. 7 plus 3. So dividing by 2 gives you the coordinates 4, 5. The next bit of working is to work out the gradient of BM, because you need a gradient and a coordinate for an equation. So the gradient formula is y2 take away y1 over x2 take away x1. I'm looking at B and M, the y coordinates first. Let me just put in what my M is. My M was 4, 5. So y coordinates 5 subtract -5. 4 subtract -1. Giving me 2. And then the last step is to substitute in the coordinate B or M, but you're probably better off to substitute in B because you know that coordinate was given in the question, so it's definitely correct. So I'm going to substitute -1, -5, and also 2. Sub that into the equation of a straight line formula. And then break the brackets, add on, or sorry, subtract the 5. So we have our equation of the median from B there. Part C, find the coordinates of the point of intersection. So there's 2 methods you could use here. So let's go for this method first. For the point of intersection, y equals y. I'm going to look at my answers again. So for the equation of the altitude, if we were to have y equals, this would be y equals 1/3 x minus 4/3. Now we could use this and use simultaneous equations, but I'll do that in a minute. So 1/3 minus 4/3, and we had 2x minus 3 for the other equation. And we're going to set y equal to y. So we have an equation with fractions here, 1/3 x minus 4/3. I'm setting that equal to 2x minus 3. We have the same denominators here, so all we have to do to eliminate the denominators is multiply by 3. Multiply everything by 3. So that becomes x minus 4 equals 6x minus 9. Take off the 6x, you get -5x. Add on the 4, you get -5. So x would equal 1. And then substitute your x equals 1 into one of the equations, probably the easier one, without any fractions. So y is equal to 2 times 1 minus 3. So -1. So therefore the point of intersection would be 1, -1. If you were to use simultaneous equations, then we have y equals 2x minus 3. We also have x minus 3y equals 4. So what I'll do is I'll just rearrange these so that we have equals -3 for the top one. So -2x plus y equals -3. And x minus 3y equals 4. We could solve these simultaneously, so you can either eliminate the x's or the y's. So if I want you to times this one by 2, keep the top one the same, I'll get 2x, minus 6y equals 8. To eliminate the x's, I will need to add -2 plus 2 to get 0. 1 plus -6 is -5. -3 plus 8 is 5. So y is -1. And then I would just substitute the y into one of the equations. Maybe equation 2 again. X minus 3 times -1 equals 4. So x minus -3 equals 4. Something plus 3 is 4, so x is 1. So you can decide on which method suits you. Don't be afraid of fractions though, just eliminate the denominators.